In this video, we're going to talk about more fundamental principles of hypothesis testing. So, how do we know whether to reject or not reject the null hypothesis? First, we must remember an important principle in hypothesis testing. Say, for example, our null hypothesis is that the mean is equal to 7 days, and that our alternative hypothesis is that the mean is greater than 7 days. And say the researcher got a sample size of 25 and the sample mean is 8. Normal mathematics would tell us that since 8.6 is not equal to 7, but rather 8.6 is greater than 7, then we would have now to reject HO and we will conclude HA. However, this is not always the case in statistics. The case in statistics, because just because 8.6 is greater than 7 does not mean that we must reject the null hypothesis right away. There are many possible samples of size 25 that could have been taken, and not all of them will give us mean greater than 7. So if you would remember, in our sampling distribution, we can have a lot of samples. So say, for example, this is our population, and we can have different samples, and these samples would have different means. Some would have a mean of greater than 7, some would be equal to 7, and some would even be less than 7. We do not reject or do not reject a null hypothesis simply by comparing the sample value with the hypothesized value. It is possible that the sample value is not larger enough, not smaller enough, or not different enough from the hypothesized value, statistically speaking. So this would mean that even though our example a while ago of 8.6 is not equal to 7, if we would get its difference, so that's 8.6 minus 7, we'll have a 1.6. This 1.6 might not be large enough, not large enough for us to say that they're different. Or the 1.6 can also be said as if whether it is significant or not, because that 1.6 difference might not be significant. So we can simply say that 8.6 and 7 are statistically the same because 1.6 is not significant. Instead, we should compute 4 and determine other important values and do 3 other steps. So these are the steps of a formal hypothesis test and a p-value approach. Number 1, state the null hypothesis and the alternative hypothesis. Number 2, compute the value of the test statistic using sample values. Number 3, compute the p-value using the value of the test. Number 4, compare the p-value with the chosen level of significance and state the conclusion. So, there is actually another approach in statistical tests called the critical value approach. However, modern statisticians would rather use the p-value approach because this is the one more convenient using statistical software programs. In the next video, we'll talk about formally how to do a hypothesis test.